Welcome back. I hope you're doing great. As a part of this video, we'll understand high-level techniques for test case design. In the previous video, we understood we have to design test cases by using techniques so that we will be able to come out with the test cases considering all the permutations and combinations and execute the test cases in an optimized way to uncover more defects in less time. So high level techniques and low level techniques would help us to design the test cases. Here in this video, we'll understand some of the high level techniques. So in the high level techniques, the emphasis is on specification. When I say specification, requirement specification. What we will do as a part of this technique is we'll express the requirements in a simple formal notation so that it is easy to design the test cases. And the notation helps us to generate the scenarios. After we come out with the formal notation, we'll be able to come out with the different test cases for each scenario. Then it will be easy to verify the requirements and find any defects in the requirements. Let us look at some of the high-level test case design techniques. In case of high-level techniques, we do have techniques like state transition, flowchart, use cases, decision table, and Boolean logic. Let us see couple of these techniques as a part of this video. What is state transition? Are you going from one state in India to another state, or are you transitioning from California to Illinois? We're not talking about the transition here. We're talking about a state transition high level technique to design the test cases. Whenever there is a system which is transitioning between the different states, that is when we should use the state transition techniques. And state transition would be useful in any system that can give different output for the same input depending on the outside conditions. So what happens as a state transition is testing team would provide all the negative and positive test values to evaluate the system. So by using this approach, tester would analyze the behavior of system under test for various input conditions in a sequential manner. We should focus on state transition whenever the testing application is done for the limited set of input values. As we already indicated, we'll use the state transition when we have to test a system with a sequence of events. What is an example for a state transition? Assume you are planning to log into your email. All of us would have logged into email, right? If you're taking this course, definitely you'd have a login ID, you'd have an email, and you would log into email. This can be considered as a state transition. How? If you want to log into the application, what will you do? You will provide a user ID and password. In case you forget your password, after 3 to 4 attempts, depending upon the type of systems, your system gets locked. So what is happening here is system is transitioning from a available state to a locked state. That is a simple, wonderful example of a state transition. So what is this use case under the high level technique? Whenever you have a system, for each of the system, there'll be some different use cases. So what we'll do in this is we'll attempt to understand the use cases of a system and design the test cases based on the use cases of your application. So all the use cases put together will help us to completely test the functionality of the application. So that way, right from the login till reporting or any set of functionalities will be able to cover by using the use cases technique. Then flowchart or control flow. What is happening here? In this case, we will try to determine the execution order of statements or instructions through a control structure. What will happen is a part of a large program will be selected by a tester to test the testing path. So once we come out with the flow chart or a control flow, test cases are designed through the flow graph of the programs to determine the execution path is correct or not. So we'll look at the business logic and depict that in a flow chart or a control flow. Then we'll see how many paths are there, and for each of the path test cases are generated. Then it is very simple to use. For every condition we'll generate the test cases using boundary value analysis and equivalence partition, which is covered as a part of the low level technique. Awesome, we understood some of the high level techniques for test case design. Thank you.